This question has another big idea, and the main difference that we notice is now inside our function that we're trying to solve, there's a number. There's a 3 inside of our function. So that's like a horizontal compression. How is that going to affect our solving of a question? And I give these kind of questions a special name. I don't know, I made up this name. I call them multi-revolution questions. I find sometimes when you give something a special name, then you remember how to do it better. So we're going to call these ones multi-revolution questions. And the reason is we're solving between 0 and 2 pi, but instead of having an x inside of sine, we have a 3x. So I'm going to give you a little example. If I got everybody in here to choose a number between 1 and 10, there'd probably be some people that pick 5, some people that pick 3, some people pick 7. And whatever number I say, pick a number between 1 and 10, now multiply it by 3. Okay? What are the numbers going to be between now? Will I have anybody who has a 1 anymore? No. What's the smallest number someone could have? They could pick between 1 and 10. And let's say you're allowed to include 1 and 10. Then the smallest number someone could have after I tell you to multiply it by 3 would be 3. And the biggest number someone could have would be 30. Okay? And you could have any number in between. Although if I ask you to choose between 1 and 10, probably nobody picked 7.2. But you could, because that is a number between 1 and 10. So now your answers are going to be between 3 and 30 if you multiply by 3. Now for this question, x is between 0 and 2 pi. So my question is, what is 3x going to be between? 0 and 6 pi. And if we think about our unit circle, and we think about going from 0 to 6 pi, can you see that that's 3 times around your circle? And that's why I call these multi-revolution questions, because we're going around the circle more than once. So how do we solve multi-revolution questions? Because this question is, I have sine 3x equals 0. Well, we solve it like normal. We just sort of imagine instead of a 3x, what would we do if this was sine theta equals 0? Well, you would say, that's on my pi plate. When is sine equal to 0? When is the y-coordinate equal to 0? 0, pi, and 2 pi, right? Now, that's what you would do if it was just sine theta equals 0. But this is a multi-revolution question, and instead of theta equals, we're going to have, because we have 3x instead of theta. So we have 3x equals. But 3x needs to be between 0 and 6 pi, 3 times around. And we just did from 0 to 2 pi, which is the first time around. What would the answers be if we went a second time around? Three pi and 4 pi. And what would our answers be the third time around? 5 pi and 6 pi. So that would be 3 full times around. Now at this point, I want to do a quick check of my domain, and I notice that, see here that the domain that's given has 0 less than or equal to x less than 2 pi. They don't have the equal sign there. So that is going to affect, because I wrote an equal sign here. So I'm going to erase that equal sign here. That would mean I'd also have to erase that equal sign there. And it's less than 6 pi, not less than or equal to 6 pi. So we have to be careful, because they actually want us to not include that answer. So that means that 3x is equal to 0, pi, 2 pi, 3 pi, 4 pi, and 5 pi. And if we want to find out what x is equal to, what would we have to do to each of those answers? Divide all of them by 3, pi over 3, 2 pi over 3, 3 pi over 3 is just pi, 4 pi over 3, and 5 pi over 3. And notice once you've divided them all by 3, are all 6 of those answers between 0 and 2 pi? Yes, they are. And so on a multi-revolution question, you might have to solve it first many times around, and then when you divide, all of your answers are between 0 and 2 pi like you wanted them to begin with. Now in part B, it says state the general solution. The general solution, what were our steps for that? Step 1, solve like normal between 0 and 2 pi. We've done that. We've got 6 answers between 0 and 2 pi. So to write our general solution, we've already done step 1. Step 2 says add 2k pi to each of them. You ready? It's going to be big. Because we had 0, pi over 3, 2 pi over 3, pi, 4 pi over 3, and 5 pi over 3. And to each of them, plus 2k pi, 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 plus 2k pi. Where k is an integer. Yes. Have to write it all out. Yes.
Can we just write pi over 3 plus k pi? And k is a mixture. So it's what you did on the last one. You just take one of those.
Well, let's see. There is a way to write this one shorter. Okay? If we think about where all of these answers are. Okay, we've got 0, pi over 3, 2 pi over 3, pi, 4 pi over 3, 5 pi over 3. What is the distance between each of those? Pi over 3, right? So if you wanted to write all of those eloquently, and you could see this pattern, you could write it as 0, which we wouldn't even have to write 0, plus k pi over 3. And that would be much shorter. Okay? But if you can't see how that worked, it's not wrong to write them all out plus 2k pi. But what this answer in green says, I'm going to start here at 0. Then I'm going to go to pi over 3, get this one. Another pi over 3, get this one. Then I'm going to get this one, then this one, then this one. And I'm going to keep going. And I will get every answer and every one that's coterminal with it. What our first answer said, start with 0, add 2 pi. That'll get all of these ones. Then the second answer says start with pi over 3, add 2 pi. That'll get all of these ones. Third one says 2 pi over 3, and so on, and so on, and so on. So they mean the same thing. Sure, this is a lot nicer, but sometimes when you're learning a lot of stuff in a course, it can get confusing to remember special rules for each individual case. So if you're remembering one thing and one thing well, that I can solve between 0 and 2 pi for my general solution, and then add 2k pi to each of my answers, then that's simple, and then you can worry about other things as well. Okay, so questions that we're going to do right now for practice. Five, 6, and 10.